Believe it or not, we've come to the end of another tutorial series and the end of another year. I ended 2020 with a video called Fun Julia Projects, so I thought I'd continue that tradition and end 2021 with another Fun Julia project. In this tutorial, you'll learn how to create the famous Snake game using GameZero and Julia. There are lots of videos on YouTube showing how to create the Snake game using other programming languages. But I couldn't find a video that shows you how to make the game using Julia, so I decided to make my own video. Is the Snake game easier to make or harder to make using Julia? Well, let's find out. Welcome to Julia for Talented Amateurs, where I make wholesome Julia tutorials for talented amateurs everywhere. I am your host, the Dabbling Doggo.
I dabble.
Before we get started, I wanted to share this public service announcement. Julia version 1.7 was released on November 30th. I'm still using Julia version 1.6.3 since this entire tutorial series was created using that version. In any event, for those of you who may be interested in using the latest and greatest release, Julia version 1.7 is now available for you to download. Now, back to the show. The Snake game is an old-school arcade game that can trace its roots back to 1976. There are a lot of different versions of this game. In the version that we'll be creating, a single player controls the snake by using the arrow keys to move either up, down, left, or right. The snake cannot move diagonally, nor can it move backwards. The objective of the game is to have the snake eat an apple, which will appear at a random location in the game window. The snake eats the apple by colliding with it. If the snake eats the apple, then the snake's body grows by one segment, and then another apple appears at a different random location. Also, the game speeds up slightly every time the snake eats an apple. If the snake collides with any of the four borders, then the game ends. If the snake collides with its own body, then the game ends. Because this is an old-school game, the snake can only travel along a grid of square tiles, and the game initially moves at a slow frame rate. There's a Julia package called Snake.jl that was created by Robert Moss, which is a version of the Snake game that you can play in the Julia REPL. It's fun. Check it out. I couldn't find a version of the Snake game created using GameZero, so I decided to go ahead and make my own version. This should be a fun final project to wrap up the series and to wrap up the year. For this tutorial, knowledge of Julia and VS Code is required. I'm also assuming that you've watched episode 409, which gives an introduction to the GameZero package. Okay, let's get going. We have a lot to cover, so let's jump into VS Code. In your VS Code Explorer panel, create a new folder for this tutorial. In the tutorial folder, create a new file called rungame.jl. Also in the tutorial folder, create a folder called SnakeZero. Inside the SnakeZero folder, create another folder called fonts. Also in the SnakeZero folder, create a file called snakezero.jl. Launch the Julia REPL by using Alt-J, then Alt-O. Maximize the terminal panel. Change the present working directory to your tutorial directory. Enter the package REPL by hitting the closing square bracket. Activate your tutorial directory. Add the GameZero package as well as the colors package. Type in status to confirm the version numbers. Exit the package REPL by hitting backspace. Minimize the terminal panel. Okay, let's use GameZero to draw some actors. The first thing to do is to copy your favorite font file and paste it into the fonts folder. I'm using the Comic Sans bold font that we used in episode 409, but feel free to use any font that you like. In the Snake.jl file, add the code to initialize the game window. These dimensions are a little different than the ones we've used in the past. For our game window, we'll be using the top 120 units for a header to display the score and some other text. That leaves a 600 by 600 unit window for the actual playing field. Now that we've defined our game window, we need to define the snake actor, which is the star of our game. Our snake actor will start out as a green square located at the center of the playing field. That variable named snakeSize not only defines the size of the snake, but also defines the tiled grid that will be used as the playing field. Using a dimension of 20 units on a 600 by 600 field means that the playing field is actually a 30 by 30 tiled grid. You can change the value of the snake size variable to either scale up or scale down your playing field. You'll see what I mean in a few minutes after we've rendered the game window. In some versions of the Snake game, the snake starts with a few segments for its body. In our version, our snake will start as a single square, but will grow as it eats some apples. In coding terms, quote-unquote growing means pushing the snake head actor object into a vector named snakeBody. This vector will keep track of all of the snake's movements. This may seem a little abstract at the moment, but it will become clearer once you see it in action. So that does it for defining the snake. Next, we need to define the apple. The purpose of the function named spawn is to find an appropriate random location to place the apple. X-range and Y-range are vectors that contain all of the coordinates on the 30 by 30 square tile grid. But we need to be careful. Some of those spaces will be occupied by the snake, so we don't want the apple to spawn inside the body of the snake. In order to ensure that the apple doesn't spawn inside the snake body, this function goes through a recursive process until it finds a suitable location for the apple. Now that we have a function that can figure out where to place the apple, the rest of the apple definition is standard GameZero code that you've seen before. The apple actor is a red square with the same dimensions as the snake head. Feel free to use different colors for the snake and the apple. That's the nice thing about learning how to code. You can customize your programs however you like. For our final visual element, we need to define the header box, which is just the rectangle that goes across the top of the game window. Before we can draw our actors, we need to initialize a couple of global variables. The score will increase by 1 every time the snake collides with an apple. That variable named GameOver is just a flag that we will use to switch the game on or off. We can flip the switch to stop the game by changing the value to true. Finally, it's time to draw our actors to see what we're working with. For the most part, you've seen this code before. The for loop for the snake body is a little weird at the moment since the snake body vector only contains a single element, which is the same as the snake head. But this is the loop that will draw the entire snake body as the snake's body grows throughout the game. This next section is completely optional, but I added it since I think it's nice to see the score while you're playing the game. You can view all of my code in my GitHub repository. There's a link to it in the description below. There's no way to align your text in GameZero, so you just need to try some coordinates to see what works for your fonts and for your game window dimensions. Okay, enough with the abstract code. Let's take a look at what we're working with. Save your file and go to the run-game.jl file. In the run-game.jl file, enter the code to run your game. You should see an antique white game window with a navy blue banner across the top with a score in yellow letters. You should also see a green square in the center of the playing field and a red square at some random location in the playing field. That green square is the snake, and the red square is the apple. If you're seeing what I'm seeing, then congratulations! Getting a game window to appear is half the battle. Click in the REPL and hit Enter, and then close your game window. In the Snake.jl file, change the snake size to 50. Save your file, and then rerun your game. You can see what I mean by scaling the game window up or down. When selecting a size, be sure to use a number that divides evenly into the dimensions of your game window. I'm going to change it back to 20, but feel free to play around with this variable to find a setting that you like. Now that we have a game window with our actors in place, we can get to the fun stuff. Let's set up some code to move the snake. Setting the speed equal to the snake's size will ensure that the snake will always move along the tiled grid. By setting the Vx variable equal to the speed, the initial direction for the snake will be to move to the right, but feel free to use whatever initial direction that you like. Now, one of the challenges of using GameZero is that it refreshes the game window 60 times per second. While that may be a suitable frame rate for many games, 60 frames per second is way too fast for the Snake game. There's currently no way to change the frame rate in GameZero, so we'll slow it down by using the sleep function from Julia Base. These variables will be used to regulate the speed of our snake so that it's not moving too fast or too slow. Using a value of 0.2 for the variable named delay means that GameZero will go to sleep for 0.2 of a second in between every frame, which will essentially slow down the game's frame rate. Next, we need to set up some rules for how to handle the borders. Depending on the version of the game, if the snake collides with the border, the snake will either reappear on the other side, or the game will end. In our version, if the snake collides with the border, then the game will end. Speaking of collisions, we also need to decide how to handle what happens when the snake collides with its own body. If the snake collides with its own body, then we want the game to end. So that was a bad collision. A good collision is when the snake collides with an apple. When the snake collides with an apple, we want several things to happen. 1. The apple needs to disappear and then reappear or spawn at a different location. 2. The snake body needs to grow by 1 segment. And 3. The game needs to speed up slightly in order to make the game a little more challenging. Now that we have all the pieces in place, we need to define the update function to let GameZero know how to handle all of these pieces of code. This update function will run as long as the game over flag is set to false. The move function will move the snake without any interaction from the player based on the current velocity. The border function is just checking to see if the snake has moved off the playing field. The collide head body and collide head apple are the two collide functions that we just created. Calling these functions will check for collisions. The grow function is pushing the current location of the snake head into the snake body vector at the end of the vector. If we did nothing else, the snake body vector would continue to grow with every position visited by the snake head. In some versions of the Snake game, this is part of the game design. But in our version, we want to remove the oldest position in the vector, which is why we're using the pop_at function to remove the oldest element, which is at index 1. This will give the illusion that the snake is moving. In reality, the code is merely displaying a vector of positions and adding the current position while simultaneously removing the oldest position. So, if we're just adding an element to a vector and then removing an element from that same vector, how does it ever grow? If you look back at the collide head apple function, notice that it calls the grow function as well. By calling the grow function whenever the snake head collides with an apple, we're basically pushing the current location of the snake head twice into the snake body vector, once from this collide function, and then again from the update function. This is how the snake body vector grows in length. The length of the snake body vector is just the snake head plus the number of apples that the snake has consumed. Therefore, rather than keeping track of a score, we can just calculate it by subtracting 1 from the length of the snake body vector. Finally, the sleep function is from Julia base. The sleep function will put the entire game to sleep for the number of seconds used as the argument. Feel free to adjust the delay variable and the delay limit variable to either make the game run faster or slower. Okay, that was a lot of work. Let's take a look at what we have so far. Save your file and rerun your game. You should see the snake moving across the screen to the right, and when it hits the border, the game ends. Nothing happens if you try to use the arrow keys or clicking your mouse, because we haven't provided any instructions to GameZero yet to define the user interactions. But it looks like our game is working. We just need to set up some controls so we can actually play the game. Click in the REPL and hit Enter to break out of the loop, and then close your game window. Back in the Snake.jl file, let's define the keyboard interactions. Remember that in the game window, vertical numbers increase as you go down, which is why the down direction is positive and the up direction is negative. For my game, I'm using the arrow keys to move the snake, but you may want to use different keys. For example, the arrow keys may not be that convenient if you're playing on a laptop, or if you're left-handed. Feel free to change these keys as you see fit. The conditional statements used in this function are to prevent the player from backing up. For example, if the snake is moving to the right, then the player cannot suddenly move to the left. In order to move left, the player must turn either up or down, and then turn left. And that's it. With this code, we should be able to control our snake and play the game. Save your file, and then go back to the run_game.jl file and rerun your game. It's frustrating to watch someone else play a game, right? So it looks like the game's working. As the snake collides with the apple, the snake grows, and the score increments by 1. It's hard to tell, but the game is getting slightly faster with each apple. By the time you notice the speed increase, it's too late. When you crash, the game ends. But when you click in the game window, nothing happens. That's because we haven't added any mouse click instructions yet. That will be our final step. Click in the REPL and hit enter to break out of the loop, and then close your game window, and then go back to the Snake.jl file. Before we can add the instructions for the mouse click, we need to define a reset function. The reset function will take all of the global variables and set them back to their initial values. This section resets the snake head and snake body. This section resets the apple. This section resets all of the other global variables. And finally, this resets the game over flag. By tacking this reset function at the end of my code, I realized that it looks like an afterthought, because it is. As I was writing the code for this game, I got tired of shutting down the game and restarting it using the run game function, so I thought there should be a better way to restart the game without exiting the game window. When I created the reset function, it occurred to me that it would have been better to have this up front, since I'm basically declaring these variables twice, once initially and then a second time to reset them. But if I restructured my code to do that, then it wouldn't make any sense as a tutorial, since you'd see me resetting a bunch of variables that I hadn't explained yet. This is a long-winded way of telling you to do as I say and not as I do. There's definitely a better way to structure this reset function, so please do not use my reset code as a benchmark for best practices. My code does work, but clearly there's room for improvement. In any event, once you define the reset function, you can call it whenever the player clicks in the game window. In episode 409, I used the onMouseMove function. The onMouseDown function works the same way. There's also an onMouseUp function available as well. By using the conditional statements, the mouse click reset will only work if the game has ended, so it shouldn't work if you click in it in the middle of an active game. And that should be it. Save your file and go back to the rungame.jl file and rerun your game. Pretty cool, right? Who says coding can't be fun? Congratulations! You have made it to the end of this tutorial, the end of this tutorial series, and the end of another calendar year. I want to take this time to say thank you to everyone who has watched any of my videos, clicked on the like button, shared a video, or left a comment. I would especially like to thank my channel members, whose generosity makes these videos possible. I hope that you and your families have a wonderful holiday season, and I hope that you have a happy and healthy new year. As in the past, I will be starting my hiatus to recover both mentally and physically, and to start preparing material for another tutorial series that will start sometime in January 2022. Thanks for watching. and I'll see you next year.